Today, I want to talk about solving limits that have the indeterminate form 0 times infinity with L'Hopital's. Well, we know with L'Hopital's, it has to be in the indeterminate form, either 0 over 0 or infinity over infinity for L'Hopital's to be used. So our objective when we're doing these problems is going to be to rewrite it in one of those two forms. So let's start off with this one, right? And right here, what we have is 0 times infinity. So how can we rewrite this? Well, what we can do is we can try to take down the cotangent and make it tangent in the denominator. So we can say this equals the limit as x approaches pi of x minus pi over tangent x, right? Then from here, let's observe. Well, up here, if we put in pi, we'll get 0. If we put in pi down here, we'll also get 0. So now we have 0 over 0. So now we can proceed with L'Hopital's. So this will equal the limit as x approaches infinity of 1, because the derivative of this is 1, and then over secant squared x. Then secant squared x, this will equal the limit x approaches pi of cosine squared x, right? And then we can cosine squared x, again a little ahead of myself. Then we can say this equals cosine squared of pi, which also equals -1 squared, which equals 1. So that is our answer there, right? And as you can see, we did that by rewriting it in a different form. So let's do that up here now. So once again, we can observe this is 0 times infinity. So what we can try to do is take down the secant 2x into the denominator and make it cosine 2x, right? And let's see what happens when we do that. The limit as x approaches pi over 4 of 1 minus tangent x over secant 2x, right? Sorry, not secant. This will be cosine 2x, right? Then from here, let's observe. Well, we put in pi over 4 and we get cosine of pi over 2. Cosine of pi over 2 is 0, so that's looking good. And then this up here is still 0. So now, once again, we have 0 over 0, so we can proceed with L'Hopital's. So let's take the derivative of both the top and the bottom. We get the limit as x approaches pi over 4 of, well, this will become negative secant squared x over, this will become -2 sine 2x, right? And the negatives will cancel out, and we can rewrite this with the 1/2 outside here. Let me not forget the equal signs, right? And we'll get the limit as x approaches pi over 4 of, this will become secant squared x, and this will become sine 2x, right? So now what we're going to do is we're going to bring down the secant squared x into the denominator and see what happens. So this will equal 1/2 times the limit as x approaches pi over 4 of, well, this will become 1 over secant squared x in the denominator will be cosine squared x, right? Then this will be times sine 2x. So now let's plug in pi over 4, and we get 1/2 times 1 over cosine, actually, here. So let's observe. What is cosine of pi over 4? Cosine of pi over 4 is square root of 2 over 2. All right, so I'll have square root of 2 over 2 squared, right? Then times sine of 2x, so that'll be sine of pi over 2. Sine of pi over 2 is 1, right? So then we have this. But square root of 2 over 2 squared is also 1/2, right? So we can cancel those out, and that will equal 1. And that's our answer there. Now let's move on to this one. So as we can see in this one, there's no trig, right? So we can't move something down into the denominator like we could in the other problems. Well, that's not entirely true. We can, because we have a negative exponent, right? We don't have trig, but we can still look for something to move down. So this will equal the limit as x approaches infinity of, this will become x over e to the negative square root of x, right? So now that we're here, let's try plugging in as x approaches infinity. So this will not be negative anymore. That is my mistake, right? This will become infinity, and so will this, right? So now we have infinity over infinity. So now once again, we can proceed with L'Hopital's. So this equals the limit as x approaches infinity of, this will become 1, right? And then this will be e to the x times 1/2, because we're taking the derivative of this, right? X to the negative 1/2, right? And then we can bring all this up, and this will equal the limit as x approaches infinity of, this will become 2 square root of x over e to the square root of x, right? So then, now that we're here, what can we do? Well, let's think about this. We can apply L'Hopital's again, and there will be light at the end of the tunnel. We will not just continue to expand. This will equal the limit. And the reason we can apply it again is because this is still infinity, and this is also still infinity, right? As x approaches infinity of, and actually, before we do that, let's factor out this 2 there. That'll make it a little bit easier for us, right? This will become 1/2 x to the negative 1/2. Then this will become e square root of x times 1/2 x to the negative 1/2. I'm sure you can see this will cancel out, this will cancel out. And then this, right, will equal 2 times the limit as x approaches infinity of 1 over e to the square root of x, right? Now, as this approaches infinity, this will approach 0. So we have 2 times 0. So this was 2 times 0, which just equals 0. And that is our answer for that one. Thank you for watching my video. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.